This is the MDX Magnetron DC sputtering power supply, manufactured by Advanced Energy. Let's take a look at the connections on the back before we power it up. The connections to the power supply require an electrical service of 208 volts, 3-phase, 60 hertz, with a dedicated neutral. They use a 120 volt AC control circuitry along with a dedicated ground. Also, typically the unit is connected and interfaced to a host computer. In this case, we have a jumper plug. We will provide a pinout for this jumper plug so you can make one of your own. And as long as that jumper plug is in place in the user's port, the front panel controls can be used. Wait a minute, I want it on the off position. Okay, go. The unit is powered up with the main circuit breaker in the back. And it has 3 distinct operating modes. The first is off, where there's no way to use any of the controls. The reason for that is that they normally like these power supplies to warm up and become stable over a period of time. So they have it so it can be turned on without being operated. The next mode of operation would be the program mode. The program mode allows us to change the set points and the parameters. For example, if we were to put in 1 kilowatt, the piece of equipment is operational. Now, if it is in the lock mode, the piece of equipment is still operational. However, none of the set points can be changed. They're locked out, so the operator doesn't have the opportunity to change anything that the system manager might have set up. As far as ease of operation, it's very simple to use. Again, if you wanted, for example, to have the power regulated, you could set that for anywhere from 0 up to 5 kW. And I've set a ramp of approximately a half a second, and it ramps up to the set point of 5 kW. You can also regulate the system by regulating, for example, instead of the power, you can regulate the current. The current then allows you to change different levels, which will correspond with the voltage and still give you the same amount of power output. For example, if we were to make a set point of 7.7 amps, it should generate an output of 3 kW at a voltage of 391, just by setting the current itself. And we get an output of 3 kW, 397 volts, times 7.69 amps, close enough, which equals, again, 3 kW. You can also regulate using voltage. We have power, we have current, but if you depress both buttons, you can regulate in voltage mode. Again, from our test results here, let's say we put in 450 volts DC. We should expect to see 4 kilowatts, approximately 4 kilowatts as an output. So, and we have 8.79 amps, 449 volts, which approximately equals 4 kW, in this case 3.96. We can run that up to the limit, up to 500, but you'll notice when you start to go over the limit, it'll start to signal you that you're pushing things a little too hard. Push the button. And we are up to 5 kW with 500 volts and approximately 10 amps, which gives you 5 kW. And to illustrate one of the safety features, let's say you went farther. We're going to put in 510, which is going to be over the set point limit. And as a result, the set point alarm comes on when you exceed 5 kilowatts.